Okay. Well, very good morning, guys. So last day we just been discussing about we started up the discussion about task parallelism. So in this process, first what did I say? The first thing what did I say is just guys, multi-threading. Let's just start from there. Let us just start from there. Okay. So I'm going to create a console application project here. Long back we worked with console. Let's again go with the console application development. Create a new project. Console app. I'm giving the name of the project as TPL project. Click on the next. Choose .NET 6.0. Choose .NET 6.0 long-term support. Okay. Next. Do this also here. What is it? Check the checkbox. Do not use top level statements. Clear? Check the checkbox. Which one? Do not use top level elements. Top level elements or top level statement? Top level statements. Sorry. Top level statements. And click on create. Okay. So that's what you're just going to do now. Okay. Come on, let's check the checkbox and click on the create button. So by default, the project comes with a class. What class? Program. Program is a class what we get by default. Okay. And now I just wanted to write some simple code in that. 3 methods are what I'm defining in that. You know them. Nothing to explain. Watch. Static void print 1, print 2, print 3. What are they doing? They are basically going to print from 1 to 100. And in this process, I'm just trying to show you one thing. What's it? What is the name of the method? Print1 method. Afterwards, I'm trying to show the thread ID. I'm trying to show the thread ID. Thread ID. What is this thread ID? The thread ID means every thread that executes your code will have an ID. Right now we have only one thread. What is that? Main thread. The ID of it. So for all the 3 methods, the thread ID will be same. For all the 3 methods, the thread ID will be same. For understanding here, I'll just say thread ID. Array, this is just a minute. I'll change the code. First, I'm printing the thread ID, guys. Afterwards, print one method, I value. Array, print one method and the I value. That's what it prints to you. So what it prints you? What is the thread ID? Afterwards, the method and the I value, 1 to 100. Okay. Same thing I am going to do for all the three. Here this is print 2 and here this is print 3. Yes, you know that if at all you want to use threading in your code, you require to import system.threading namespace, correct? But exactly we are working on C#10, and we don't require to import it. Why you don't require to import? The reason why you don't require to import is because that is already imported, default import. System.threading is already imported. Just last week only, remember I showed you that also one more time. The system.threading is already imported for you. So no need of importing it again. Otherwise, if you work with any old project, when I say thread, I'll immediately get an error. Why? In the video you watch, thread is present on the system.threading namespace. Here I don't require to import, so no need of importing system.threading in the code. Okay. First, let us write a program without using multi-threading. And to do that, write the below code in the default class. Which class? Program, which is present under program.cs file by deleting the existing code in the class. Just delete of the existing code in the class here and write the code now. Okay. So this is all what I'm writing. Yeah, fine. And now let's go to main now and call the methods. Guys, I defined the methods as static here, directly I can call. But in the video, see, I defined all as non-static. In the videos I showed you non-static, here I'm showing you static. But non-static, how do I call? I created instance and called. Because static, I can directly call. Now. Print 1 is the first method. Print 2 and print 3. And all of you put this in the mind. You are running your code in single threaded model, right? Because you're running in single threaded model, first method 1 will execute, method 2 will execute, method 3 will execute. Are you clear? Print 1 method, print 2 method, print 2 method. Run and watch the output. Start here. Print 1 method, 1. Print 1 is executing, say, completed. Now started, print 2. Print 2 is executing. Now started, print 3. Print 3 is executing. Did you notice the thread ID for all the 3? Same. Why? All are executed by the same thread. Which thread? Main thread. And the ID of the main thread is 1. The ID of the main thread is 1. And you guys, you remember what is the drawback in this approach? The drawback in this approach is if any thread is taking more than the expected time, then we get wrong results. Suppose, for example, this method is taking more than the expected time. So how to do that? Tomorrow in the real time, any scenario here, I'm contacting a database, the database is not responding faster, network issue, anything can happen. But for simulating, I shown you an option. What is that option? Sleep. For simulating the things, I shown you an option. What is that? Sleep. So if I value is equals to 50, I'm writing here thread dot sleep for 10 seconds. See now, print2 method cannot execute after 50 for 10 seconds. And who is suffering now? Print3 is suffering. Okay, run and watch. See there. Print1 started and it stopped for you at 50. After 10 seconds, it will wake up, complete the work, and then only print3 will execute. So print3 is waiting until print2 completes the work now. Now it completed. Now the rest of the code got executed. Didn't I change the things here? Just a minute here. Oh, I did not change here, guys. Okay, fine. Yeah, stopped it here. Now after 10 seconds, it wake up, completes print2 and goes to print3. This is the drawback what we have in a single threaded model. A single threaded model. Now see, print3 completed, but 10 seconds, its time is wasted. 10 seconds of its time is wasted in this process. But as of now, that is a mechanism how the execution takes place for you in a single threaded model. I hope you guys are clear. Okay. Now, can I improvise this one now? Means, can I make it multi-threaded now? Right now it is single-threaded model, right? Let us make it multi-threaded. If I make this code multi-threaded, what is the advantage? If you make it multi-threaded in that scenario, what will be the advantage? Means you can execute each method by using a separate thread now. Every method can execute by using a separate thread. If any method is taking more than the expected time, then the other is not going to suffer there. The other one is not going to suffer there. The others are not going to affect, or others are not going to suffer in that particular place. Okay. So you can turn up your code into multi-threaded now. And if it is multi-threaded, you just have the benefit of, yeah, it executes based on two principles as we learned. What are the two principles? Time sharing and maximum utilization of resources. Two important things. One is time sharing. Second one, maximum utilization of resources are the two important features what it has. Yeah, I will show you. Okay. Fine. Code, we have defined three methods. We have defined three methods in the class, and then single threaded model. We just call them in a single threaded model. So each method is executed one after the other, and all the methods are executed by the main thread of the program. Who executes all the code? Main thread. Executed by main thread. And we can see the ID of the thread. We can see the ID of the thread, which will be printed by the statement system.currentThread.managed thread ID. Understand the statement here. Thread class. Under that, current thread refers to the current thread. managed thread ID. That will print you the ID of it. Okay. Now let us rewrite the above program using multi-threading. Let's go for rewriting the above program by using multi-threading. And to do that, I'm adding a new class in the project. Add a new class. No need all these things now. No need to import any of these things for us. Okay. Now let me copy the three methods as is. Let's go to main. Let's go for calling them by using threads now. How to do that? Thread T1 is equals to new thread. No need object dot, but in the videos it is object dot because they are non-static. Because I showed all non-static there, here I'm showing you static. That's it. Done. What next? T1 dot start, T2 dot writing.
Recording
What?
in progress.
The main thread ID. The main thread ID now. What is the ID of the main thread? Main thread. And here it will print you ID. Is exiting. Is exiting. Okay. Now let's run this code. Yeah. Startup object TPL project dot class one. TPL project dot class one. Run. And now you are using multi-threading. Because you are using multi-threading, you guys can observe there is a time sharing what has been applied. Print one started. In the video, that's not in my control. That's controlled by operating system. How much time a thread is given means I don't know. I can't tell that. Is executed by a separate thread with ID 11, and the print 3 is executed by a separate thread with the ID 12. So 10, 11. First one is main thread. You can't escape from that. Afterwards, there are all the subthreads what are created. See now, all are executing now. Time sharing. So everyone is given equal preference. Everyone is giving equal preference. You see, in the last, what is it telling you? Main method. What is the ID? Exiting. But now you did not see. Where is it? You'll find somewhere in the middle or top. Where is it? I don't know. Starting only, Lord, is easy to see. This should not happen. So to control this, what should I do? Join. I should call the join. And in this process, if any thread is taking more than the expected time, this also, what is that? If I is equals to 50, I'm writing thread dot sleep for 5 seconds. Yeah. And in this time, you remember all of you guys, what will happen? Okay, 10 seconds. 1 and 3 will complete their work, leaving the 2 there. Okay, you can see the output. And the 2 seconds you wait there, 3 completed its work already, and 1 completed its work already. And it's waiting there after 10 seconds, it will wake up and see now, you can see, woke up and completed its work. But now also, main thread is waiting until all the threads saw in the
Recording in
videos, nothing
progress.
new. What now is, listen all of you, there is a problem now. What is that? Not any error or anything, just carefully listen. There is a problem now. What is the problem, sir? The problem is in multi-threading, actually, when you are multiple operating system will create multiple threads to you in the code. In multi-threading, the concept is like operating system creating multiple threads in the code. How many threads will it create? It will create you the number of threads. How many you asked for? How many you asked? That many number of threads are created now. Am I right? Now see guys, what I'm trying to tell you is, you know, like quad core processor, octa-core processor, hexa-core processor. Aware of that no? Mine is a quad core processor. Means every processor is a logical unit. Every processor is a logical unit. So if you are not good about that, just Google and read about the processor. What is meant by multi-core processor? Every processor is a logical unit which is going to execute your code to speed up the things. Normally, we use quad core processors, but servers and all Intel Core multiple 8 cores, 6 cores like this. If you go to Intel website, you'll find it much detail. Missed it. Yeah, this is the page. The Intel Core X series processor, 18 cores. Intel Core i9 processor, 16 cores, 14 cores. Like this, 12 cores. More the number of cores, the cost increases now. The cost also will be increased for you in that way. So these are multi-core processors actually. These are all multi-core processors. So today, mine is a quad-core processor. Means how many cores are there? 4 cores. Now how many threads are execute created for me now in my program. By default one, and under that I created 3 more threads totally. Under the same code only, all threads will be created actually. Did you catch my point or not? Okay, will be created under the same code. But actually the concept of the course is increased performance, means multiple logical units, which will speed up your performance. But unfortunately, even though we have a quad core processor and I'm creating multiple things here, all are getting created under the same core now. And actually the concept of task parallelism started here. What is task parallelism? You know, the task parallelism basically is about, that is also threading only here. That is also threading only. But if at all you're working with a multi-core processor, and if at all you're creating multiple threads, task parallelism has introduced the concept of creating multiple threads for you, each thread on separate cores. That's all. Apart from that, this is also threading only. This is also threading only. But now in the place of thread, it has given a class called task. What is the class name? Task is the class name. You don't create thread now. What you create? Task. When you create this task now, what happens behind the screen here? For every thread will try to run for you on a separate core. See, 4 threads, 4 cores. If there are 8 threads now, two threads will go to each core now. Means you're trying to utilize all the cores of your processor. Understood my point? Doesn't mean that, sir, if I create 10 threads, do I need 10 cores? No. We'll distribute that between multiple cores. Earlier, 10 created on one core. Earlier, 8 are there here. 8 created on one core. Now, 2 on each core. Are you not distributing the work now? That is what task parallelism. That's all. Nothing more than that. Whatever I explained in the videos of your multi-threading, the same thing will come for you here. But you will be writing the code in a different style. That's all. Apart from that, there is no difference between a task and a thread. But now you will not create a thread directly. What you will create? Task. A task will create a thread. You will create a task. A task will create a thread on a separate core. If I have 4 threads, 4 tasks now. I'm sorry. If I have 4 threads in my code, the 4 threads will be going and occupying the 4 cores of my processor. Will go and occupy the 4 cores of my processor. Apart from that, you will not find any difference between the task parallelism and the multi-threading, what you have already learned about. Okay, now, let's see that. Let's see that, guys. See, in the above program, in the above code, separate threads. So each thread will execute one method concurrently. Each thread will execute one method concurrently. And in the program, we will be having 4 threads along with main thread. You can see the ID of those threads, which will be printed by the statement system.currentThread.manage_thread ID. I shown you now. Different IDs are there. Okay now? So fine. So those threads will be having different IDs now. Okay. Now let's write the above program using task parallelism. Let's write the above program by using task parallelism. Okay. First, let me show you task parallelism. Then I'll guess the description. I said you already know. Why you again ask this question? Class 2. Now, watch. Actually, to work with the tasks, you require import a namespace system.threading.tasks. System.threading.task is the namespace, guys. But that is also default imported. System.threading.tasks is what we require, and that is also by default imported for you, and you don't require to import it separately. Okay. So, come on, let's do one thing. What did you write in class 1? These 3 methods. copy as is, paste it. Copy as it is and paste it. Find main method, start. Instance, what do you create? Task T1 is equals to new task and specify the method name. What is the method name? Print1. Print2. Print3. T1 dot start. T2 dot start. And T3 dot start. Same here, everything same. Okay, and just a second. Here also I'm writing this one. What? Main thread with thread ID is exiting. Main thread with thread ID is exiting. Okay, just I did not call join. I did not call join. Hold on a second. I'm running to, and guys, you will see the same output and you will see thread IDs, everything will be same on. But this is going to be faster. This is going to be faster. Why this is going to be faster means, what happened? Yeah, you see main thread exited off here. Main thread got exited off here, and this is going to make your code to terminate off here, not executing properly. So to make the main thread to wait, T1 dot, not join guys, wait. You'll understand it much clearly when you just work with a TPL. If a main thread exits the code, what is the problem? You saw now? Main thread exiting, it's stopped off now. Now I made the main thread to wait. In multi-threading, we don't see it correctly. Even main thread execute, also code will execute, but here it won't execute. Main thread goes means your program won't execute now. This is a perfect way. This is a perfect thing to understand. Why to make the main thread to wait? If the main thread goes out, program terminates now. You saw there now? Exiting. So now you can observe, all of you, it was using the same concept of the threads only. Now also threads are created. Now also thread ID printed, see? Now also threads are there. But this task is a wrapper for thread. On the top, task will be there now, and task will be managing the threads to you. I call wait. Task will go and call join. Understood? I call wait on the task. Task is going to call join on the thread. So I don't create a thread now. What I create? Task. And this task will create a thread for you. So how many threads are there? Now also 4 threads. Now also 4 threads here. But these 4 threads might be distributed between the 4 cores of my processor. That's not in my control. Maybe 2 can be on 1 core, 3 and 4 can be on 1 core, or we don't know that. But one thing is guaranteed. They'll be running on multiple cores. Not on a same core. Without running on the same core, they will be running on the multiple cores. And here you can just say all code executed in the same pattern what we learned. And finally, main thread ID. Now see, 9 is 1 thread ID, 5 is 1 thread ID, 8 is 1 thread ID. So 5, 8, 9 are the thread IDs we have now. Hope you are clear. Yes or not? Okay. Now see guys, actually they have simplified this coding a little bit. They have simplified this coding a little bit. Without creating a task, without calling a start method, without again calling wait separately. Just watch it, have a look. You can write this code in another way. How you know? Watch. Task T1 is equals to task dot factory dot start new. Sir, what is this? No need to call start method again here. No need to call start method again. This will start you. Sorry. Means, you see, what are you doing first? Creating a task. Afterwards, start. Without that, you can write off in one statement like this. Okay. Now run this. At about wait. You did not call a wait here. Problem see, if I don't call wait, now also problem start came now. If I don't call wait, now also problem came now. Okay. I need to call wait. Without calling wait for multiple times, you can do it like this. Task dot there is a direct method called wait all. And this wait all method, what is it taking? See, task array and with a params keyword. You remember, if there is a params keyword for an array, you don't require to create an array. You can pass the list of values and the array is constructed internally. We learned in our object-oriented programming already. So what I can do, I can directly say T1, comma, T2, comma, T3. An array is built for you directly inside of it. So now this is one style of writing the code and this is another style of writing the code. Much simplified without calling start, start, start. On the same line, you can say start new. And in the next line, you can say wait all. And you can give the list of all the methods what you just wanted them to wait there. Is that clear? Run it, you'll get the same output, only no difference. Exit. Understood me? So the thread IDs are different now, 5, 3, 8. That's not in our control. One thing is, main thread ID will be 1 year. Remaining thread IDs are given by OS. And what ID it is associating, I don't know. So you can write either in the first way or either in the second way. So you can observe here. Yeah, the task parallel library is a set of public types. System.threading and system.threading.tasks. Namespaces. The purpose of TPL is to make developers more productive by simplifying the process of adding parallelism and concurrency to applications. Yes, it is just trying to simplify the work. That's it. The TPL scales the degree of concurrency dynamically to most efficiency. Use all the processors that are available. All the processors that are available to most efficiently use all the processes. In addition, the TPL handles the partitioning of the work, the scheduling of the threads on the thread pools. Means it is going to partition the work for you into different processors. Okay, of the threads actually. Scheduling of the threads on the thread pool. Cancellation support, state management, like various other features are there. We'll see them going forward. And other low-level details. By using TPL, you can maximize the performance of your code while focusing on the work that your program is designed to accomplish. You can increase the performance here. The main goal here is threading increases performance, already we learned. TPL still increases the performance. More than threading. It's beyond threading. So that's what. When TPL came, actually TPL was introduced in .NET Framework 4. That's why the videos are talking about multi-threading. The videos never talked about TPL there. Why? This came in .NET Framework 4. Before we don't have TPL. What we have first is only multi-threading. So starting from .NET Framework 4, the TPL is a preferred way. The preferred way to write multi-threaded and parallel code. Multi-threaded and parallel code, it's a preferred way. However, not all code is suitable for parallelization. For example, if a loop performs only a small amount of work on each iteration, or it doesn't run for many iterations, then the overhead of parallelism can cause a code to run slowly. What you're telling is, we cannot use a TPL or parallelism in all the places. I will show you practical examples to you. What you're telling is, when you're writing loops, if you have big size loops, parallelism can be used. If at all you have small size loops, parallelisms will cause problems. I'll practically show them. I will practically show you about that. Okay. So here it is saying, for example, if a loop performs only a small amount of work on each iteration, or it doesn't run on for many iterations, then the overhead of parallelization can cause code to run slowly, to run more slowly. Okay. So I will practically show you. Further, parallelization, like any multi-threaded code, adds complexity to is going to add the complexity to the program execution when you are executing small amount of code. When I should use this parallelisms and all is when your amount of code is going to be huge in size. I will practically show that example to you. Okay. Although TPL simplifies multi-threading scenarios, multi-threaded scenarios, it is recommended that you have to have a basic understanding on threading concepts. For example, locks, deadlocks, all these things you should have a basic understanding about them. Without understanding threading, you won't understand parallelism. That is why I asked you first to watch multi-threading, and then only we can understand the TPL much better. So that's what it is telling. So better first you should have a complete knowledge of threading, then TPL will become easier for you. Okay, and the first example is with threading I shown. Second example, first example, no threads. Second example, with threads. Third example, I replaced the threads with tasks. Then let us rewrite the above program using task parallelism. And to do that, add a new class in the project, naming it as class2.cs and write the below code in the class. We are writing this code. Yeah, guys. Okay, just a second. Just a minute. This is the code. See, in the above code, in place of threads, we have used tasks. And these tasks will internally use threads. These tasks will internally use threads to execute the code. And the wait method we have called here is the same as join method we used in threads. There we used join, here we used wait. Okay, the process of creating tasks, calling start and wait methods, can be simplified and implemented. Methods can be simplified and implemented. That is, we can implement the first 5 lines of code in the main method of the above program as following also. That code can be implemented like this. Are you clear? We can implement the code in main method. We can implement the code in main method of the above program as following also. This is the second way of writing the code. What's it? How did I write? Like this. Is the second way how you can write your code. Okay now? Fine. So what we learn now? From now onwards, we won't create threads. What we create? Tasks. Tasks will occupy the place of the threads from now. So no more threads. It is always completely tasks. So thread is to improvise the performance of the application, and the tasks will improvise the performance of threads also. Thread will improvise the performance here, but task will improvise the performance of threads now. So it is just going to be improvising the performance of the threads now, and that is the beauty of the tasks what we just have. Okay, so now let me show you few more examples with these tasks. How to call a value returning method by using a thread. How to call a non-value returning method by using a thread. All these things I'll show you. Okay, now? So first we'll see calling value returning methods. And right now what we called here, we called a method which is non-value returning, which doesn't take any parameters. The print methods what I written are non-value returning and also non-parameterized. Now, what I wanted to demonstrate you guys is how to call value returning methods, how to call value returning methods, and how to call methods with parameters. Let us see about this process now. Okay, just a second. Yeah. Okay. Your main method code, just try to implement it like this. Okay. What next? Next thing is, just a minute. Yeah, have a look, guys, about this one. In the above code, factory is a static method. Factory is a static property of the task class, which will refer to task factory class, and the start new method of task factory class will create a new thread, starts it, and returns the reference of it. Basically, what will happen, here what are you doing first? In the first one, you are creating a thread, you are calling start, correct? But here, there is a thing called factory. What is this factory? Look at all of you. Factory refers to, it's a factory, guys. What a factory does? I'm asking general question. What factory does? Factory produces. What the factory will do? Yeah, factory will produce the goods now. Am I correct? Now the task factory class actually produces the tasks now. Whenever I call start new, what is its job? It will create a new thread now. It will create a new thread and starts it. It will create a new thread and starts it. And finally returns the reference of the thread. So this is not an instance, this is a reference. It is going to create the reference. So T1 is the reference of the thread, that is the task produced by the task factory. Are you clear? So here you are only creating the thread. Here I am not creating the thread. Who is creating the thread for me? The task factory class is creating the thread. And after creating the thread, it is just going to return me the reference of that particular thread now. And what am I doing now? I am just using that reference and I'm just calling the wait all method on that also. Okay, note. In the above program also, we have defined 3 methods and calling them by using 3 separate threads. In the above code also, we have defined 3 methods and calling them by using 3 separate tasks. 3 separate tasks. Okay. So each task will execute one method concurrently. Each task will execute one method concurrently. In this program also we have 4 threads along with the main thread. Now also we have 4 threads here along with the main thread. And we can see the ID of those threads in the output. We can see the ID of those threads in the output. Yeah, the output is printing the ID of the threads. So what I'm trying to tell is, now also threading is present, but you're not creating a thread directly. What you create is a task, and task will create the threads for you. That's it. Okay. Now the second example what I'm showing is calling value returning methods by using task. And right now our code is non-value returning, right? Yes or not? Now I want to call a value returning method. How do you call a value returning method? Watch it, guys. Let me add a new class. Then I'll tell you parameterized methods. So first let us start with value returning methods. A simple method here, a very simple method, easy to understand. All of you observe it, what I'm doing. Can you understand what I'm doing? Four lines of code is there, and what I'm doing is you're breaking off your head to explain me that. What am I doing? Tell that. Length of? Oh, that's all over. Huh? I've written 4 lines and you're telling simple 1 line, last line, that's a length of string. What is happening in the method? Tell that. Why task came for you now? What is happening in the method is my question. That's all. Brainless fellows, you're concatenating from 1 to 1 lakh. You understand the code 4 lines, you're not able to understand what should I say you here. A for loop now. What is the for loop doing? Concatenating from where to where? 1 to 1 lakh. So 1, 2, 3, 4. Like this it is concatenating. After concatenating all the values, finally I'm finding what is the length of that now. That's what I'm doing. I'm writing a method for concatenating from 1 to 1 lakh and finally returning the length of that string. What is the length? I don't know. But concatenating means not adding, guys. It will add you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, like this up to 1 lakh. It concatenates. After concatenating, I'm trying to find out the number of characters that are present in the string now. That's what I'm doing actually. And returning that. So it is a value returning method now. I want to call it by using a task. How do you call it? Watch. Task T is equals to new task of, pass the method name. What is the method name? GetLength. Now guys, your method is value returning or non-value returning? Louder. Earlier your methods are non-value returning, so I did not get any error. But now my method is value returning, so that's why I'm getting an error here. Why? If it is a value returning method, you need to use a different task class that is generic. That is how you should specify that. Task of int. So we have 2 task classes. Just like see, stack is there, stack of int is there. Array stack is non-generic, stack of int is generic. Q of t. Linked list of t. Sorted list of t. Array list, the array list name got changed, list of t. Hash table, dictionary. Everything we have 2 options now. Same way we have a task class which doesn't take a parameter, and we have a task class which takes a generic parameter. Today, the return type of the method is integer, correct? I said task of int. If the return type of the method is a string, I will say task of string. If the return type of the method is a double, I'll say task of double. And do you guys remember when you try to create the instance of the class by specifying a type, all the members of the class will change their type internally now? Yes or not? All members will change the type. Now, T is which type? Sorry, task is which type? Integer type. What are they taking? Integer. So all the members of the task class will take int as a parameter and will return int as a value. If I say task as a string now, all the members will return strings now. So automatically the code changes for you inside of the class. Okay. So this is the process to create a task now. What next? T dot start. We'll start the task now. Now, once execution is completed, you want to capture the result, correct? Come on. Once execution completed, you need to capture the result. When to capture the result after execution is completed? So now, tell me, does it require to wait until the execution is completed or not? Tell me fast. We need to wait until the execution is completed now? Actually, after completing, see, how to wait? T dot wait. T dot wait. Yeah. T dot wait. And now you need to capture the result. To capture the result, T dot result. What did the type say? Integer. Why integer? Because your task is integer. Suppose your result is string now. What should I do? Task of string. What will I get now? T dot result will be string now. If your result is double, what do you say? Task of double. So result will return double. Right now it is int, so it is returning an integer. Okay? T dot result. And now all of you can observe. I'm just going to say int result is equals to T dot result, and then console dot write line value of result is plus result, or otherwise put a dollar and write the code. So this will print you the final result. Come here, execute. It takes time here. Why? You're concatenating from 1 to 1 lakh. It takes time. Okay, let it run. We'll get the result. We'll see that. But did you understand how to call it? Tomorrow, if you're writing a method that returns a string, what should I do? I require to take a string there. For example, just hold on a second. Got it? For example, just a minute. This is get length of 1 and this is static string get length of 2. String str is equals to hello world. Return str dot. Other return type is string only now. What I'm returning is a string. So guys, can you help me how to call it? Task of string T2 is equals to new task of string and specify get length of 2. Okay now. Now what next? T1 dot start. Same way T2 dot start. You're clear with this now? Afterwards we need to call wait. Am I right? Okay. T1 dot wait. Next T2 dot wait. Now finally capture the results. How to capture? Int result1 is equals to T1 dot result. And all of you guys observe it. T1 dot result is which type? Integer type. But you guys notice it. T2 dot result. T2 dot result is a string type. See that? Because generic, we are using generic automatically. The changes we already understood about in the generics class. So how to capture it? String result2 is equals to T2 dot result. Okay. Now see, value of result1 is result1. Value of result2 is result2. Okay. Now run, you get the output. But one thing I just want to clarify you all. What you know? When you're calling result, there is no need of calling wait again, because result will internally call wait. Understand? Yeah, this is a value returning method. Value returning method means method should execute and get you the results. Correct? Yes or not? Method should execute and get you the result. So until the method is executed, result won't come now. So that is the reason why I am not responsible to call the wait now. On behalf of me, the result will internally call the wait for you. If you are calling result, automatically it will call wait and executes the code. If your method is value returning and if you are trying to capture result, no need of calling wait now. It executes without calling wait also. You can just see you get your output without wait also. Got it? Same output. Watch it. It is 4,88,895 when you concatenate from 1 to 1 lakh. And here, hello world. So whatever it is, you just, so no need of calling a wait because this result will internally call wait. Did you understand? There are two task classes, one non-generic, one generic. Two task classes are available to you. Non-generic task class is also there as well as generic task class is also there. See, calling value returning methods by using tasks. In the above programs, the methods that we called by using tasks, are all non-value returning. As well as they do not take any parameters also. Do not take any parameters also. Next example, I'm going to show you with parameters only. Hold on. Now let's learn how to call the value, how to call a value returning method. How to call value returning methods by using tasks. How to call value returning methods by using task. And to do that, add a new class in the project, naming it as class 3.cs and write the below code in it. Yeah. Just a second. I'll show you how to call in second way also. Just hold on a second. Second option is also factory.create. No, that also I'll show you. Yeah. Okay. This is one style of coding, right? Another style. Let me comment this. How you can write? Task of int T1 is equals to task dot factory dot start new get length of 1. Task of string T2 is equals to get length of 2. This is the other way of writing the code. Either the first option or either the second option. Yeah. R. Only for this code, this is common for all. Understood? Either write in the first way or either write in the second way. Whatever it is, it executes the code. So did you understand how to call value returning methods? Okay, now let us see calling methods that take parameters. Let's see how to call methods that takes parameters, parameterized methods. And I will do one thing here. Again, I have understood about value returning methods. Now we want parameters. Both at a time we'll see of what is that? Parameterized, value returning. Both we'll see. Okay now? So we can pass parameters and also we can just also return values also. Both the two things at a time I'll show you. Hold on. So See, in the above program, the getLength method, the getLength1 method, what is it doing? Of the class concatenates from 1 to 1 lakh and then returns the length of that string. Okay. So in this case, to capture that value, we need to use a task class which takes a generic parameter, t. And in this case, t is of type integer, and after execution of the method, we can capture the result by calling result property of tasks, class, which returns the result as integer. Are you getting me? Okay. In the above program, the getLength1 and getLength2 methods of the class are value returning. Okay. getLength1, what is it doing? getLength1 concatenates from 1 to 1 lakh and then returns the length of that string, and getLength2, what are you doing? Converts a given string into uppercase and returns the string. So two methods what we have just written. The first one is the getLength1. And the second is getLength2. What will getLength method do? Converts a given string to uppercase and returns the string and returns the converted string So in this case, to capture the values, we need to use the task class. Which takes the generic parameter t. And in this case, t is of type integer for getLength1 and of type string for getLength2. Okay, now integer for getLength1 and a string for getLength2. And after execution of the method, we can capture the result. By calling result property of task class, which returns the result as integer for getLength1 and string for getLength2. Return the result as integer for getLength1 and a string for getLength2. Okay, guys, that's about calling what? Value returning methods. First example is non-value returning method, calling value returning. Same way, I want to call a method with parameters now. Okay, just a minute here. Here, we'll do one thing. Let's add a new class. The same two methods in the previous program, let me copy paste now. The same two methods. But what we'll do now is, here I've taken a static value 1 lakh, right? Without that, let's go for adding int UB something. What is that? Upper bound. So now you can match that UB. 1 lakh or 2 lakhs or 50,000 are your choice now. It is dynamic now. Same way here also. Here without using a static string hello world. Let's do string str. Same only, now parameterized, but parameterized methods are dynamic now. Okay, now let's see how to call them. Static void main. Now task T is equals to task T1 is equals to new task of, carefully observe, what is the method name? Oh, just a minute. First it is returning a value now. So I should use integer. Now your method name. What is the method name? Get length 1. Guys, basically, when your just method is going to be parameterized, how exactly are we going to call is, to call this particular method, we need to just write it like this. Get length of the value what you want now. Because parameter required now. Understood? I'm passing 50,000 only now. My choice. But the syntax is a little bit different. You need to call it as like this. That is how you should do the binding. The binding process is different. You need to do the binding by using the braces, a lambda operator, and then calling the get length. Now can you tell me for a task 2? Come on, try. Task string T2 is equals to new task of string open the braces, lambda operator, get length 2, and pass the value you want in this case now. So I'm passing now hello India. Rest of the code is same only. Only the way your binding is different. Rest is same here. What is the rest same? Now also it is same thing what you do. Okay. Only thing is when you're binding them, if it is parameterized, we need to just use the braces, lambda operator, method name, and pass the value what you want. Okay, now it is 50,000. So you'll be getting a lesser value when compared with the previous one. Previously it is something 48 lakh. Oh, don't remember. Now whatever it is, you'll be getting a lesser value. Yeah, let it execute. So did you understand how to call a value returning method? Second example, value returning method with parameters. If it is non-value returning, don't use this int or string now, that's all. Parameter is the same. But don't use that int or string or whatever it is, don't use that, that's all. Taking a lot of time. 50,000 only, nah? What happened? Oh, we did not start. Oh, thank you. T1 dot start. T2 dot start. We did not start, guys. That's why you're not getting the result. Yeah, you did not get that much big value. Now it is just going to be small. Okay, now. So this is first I shown you non-value returning methods, no parameters. Second I shown you value returning method. Third I shown you value returning method with parameter. Fourth option is non-value returning with parameter. With non-value returning with parameter, what you'll do here? You will not use this. That's all, huh? What is the other way of writing this code? Task of int T1 is equals to task dot factory dot start new braces lambda operator get length of 1, pass on your value. Same. Task of string T2 is equals to task dot factory dot start new get length of 2. Hello, India. Run, you see same output now also. Okay, let execute. So directly we just calling start new and got it. Are you clear how to create the tasks now? So that is how you're just going to create the tasks here. Okay, and then we have thread synchronization. What is that synchronization? Remember, if two or more threads are trying to call the same method, wrong outputs will come for you. To resolve it, we just been discussed about lock of this. The same thing now we can apply with the threads also, tasks also. We can apply with the task also. I'll show you in the next session. We'll see you in the next class here. Let's stop here.